David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's lesson covers linear function forms. We're going to do two forms, and these are ways that linear functions can be expressed basically with equations in function form. So the first one we're going to look at is the gradient-intercept form, and that's spelled out this way: y equals mx plus b. M is our slope. Remember our last lesson we used m for slope, and b is the y-intercept. Now you will also see y equals mx plus c in our textbook, which is an international book. They use c there. In the States, which is where this class is taught, we use b here. So y equals mx plus b is our standard form, which can also be written as f of x equals mx plus b in function form. So equation form, function form, same thing. Okay, so let's take a graph and turn that into an equation. Get our equation off this graph. So the graph is f of x. So we're going to do f of x equals, we need our gradient. So here we can get the gradient right off the graph. We could plug these 2 points into the gradient formula and get it that way, but I kind of like using a graph. So our rise is down -1. So our rise is -1, and our run is over 2. So our slope, our gradient is -1/2. Bring our x down, and then b is the y-intercept. That is the y-coordinate of the point where it crosses the y-axis. So that's 3. So this is the gradient-intercept form for this graphed line. All right, let's write another line equation using gradient-intercept form. This problem is expressed a little differently. We have a line with a y-intercept of 0, -4. So we know our b already. That's -4. The rest is a little bit more tricky. And the line is perpendicular to another line with the equation y equals -7/2 x plus 6. So we know this line with the y-intercept of -4 is perpendicular to this line. We have the full equation. Now there's a little tidbit that we learned in our last lesson that's going to help you find the slope for this line. So pause the video, flip back through your notes if you need to, and write the equation for this line. Let's see how you did. This line is y equals 2/7. I just flipped this fraction and negativized it. I took the negative reciprocal of -7/2, which is 2/7 positive. So 2/7x -4, again, for my y-intercept. Let's take a look at two special cases: horizontal and vertical lines. Now, a horizontal line just has the form y equals b. This is the y-intercept. And that's just a horizontal line that cuts the y-axis in one place at b. So what would the slope of a horizontal line be? Think about that for a minute. Jot that down. A horizontal line has a slope of 0. There's no rise. No matter how much run you have back and forth, no rise. So this is 0. Okay, let's look at vertical lines. Vertical lines have the equation x equals some constant number. This is a vertical line where the x value never changes. Doesn't matter what the y value is, the x is some constant number. Now pause the video and think, what would the slope of a vertical line be? So this one's tricky. With the rise over run, your rise is whatever number you want. You could pick a bigger part of the line and it's a bigger rise, a smaller part, it's a smaller rise. The run is always going to be 0 because there's no back and forth in a vertical line. So that means we have a divide by 0 problem for a slope of a vertical line. So we don't have a slope. What we say is undefined. And this is mathematics' way of dealing with something that doesn't make sense. We have an equation to calculate slopes, but it breaks when we try to say something about a slope of a vertical line. So we basically just say, we cannot define that. We can't divide by 0, so there is no such thing as a slope for a vertical line. It's undefined. Here are a couple quick problems coming up with line equations for horizontal and vertical lines. First one, horizontal line passes through the point 1, negative 2. What is the equation of that line? Go ahead, pause the video, write that down. The equation for this line is y equals negative 2. It's horizontal, it's going through the point negative 2 for y. There's no rise or run, so y is always negative 2, like that. Now try this one, vertical line passing through the point 3, 6. Write down the equation for that one. This one is x equals 3. No matter what y is, it's a vertical line, so it's always going to pass through the point x equals 3. Let's talk about a second form for a linear function equation. This one's called point gradient form, and it's often helpful for finding an equation for a line. So for gradient m and point x1, y1, you can use this form. Y minus y1 equals m times x minus x1. And the y and the x are just going to stay y's and x's, but the y1 is going to be the value for that, and the x1 is going to be the value for that. We can simplify this on down and get back to gradient-intercept form. So that's just what we're going to do. Here's a problem. Find the equation for the line that passes through minus 4, 5 and is parallel to y equals negative 1/2 x. So go ahead and pause the video and see what you can do. You've got enough information right there to do a plug-in step here and then rearrange and turn that into gradient-intercept form. Okay, here's my plug-in step. I just plugged in my 5, y minus y1, y minus 5 equals negative 1/2 times x minus negative 4, so that became a plus 4. Then I rearranged, I added my 5 to both sides to get that over. I did my distributive property there. I got negative 1/2 x minus 2. I combined my minus 2 and my plus 5 to get plus 3. And there is my equation in gradient-intercept form. So here's a standard. If it doesn't say what form, you're shooting for this form. Okay, I want to show you another variation on finding a line equation when you're given a slope and a point. So check this out. Here's the different problem. My slope is 3/4 and it goes to the point 4, 5. So what I can do is I can start with this form. Here's y equals mx plus b. Now, I don't know b, but I know enough to find b. I know that the y value, which is 5, is going to equal the slope times the x value plus b. So this is just y equals mx plus b. I just substituted in my 4 and my 5 for my x and my y. Now I can just solve this with my algebra. This is 5 equals 3 plus b, so b equals 2. So my equation is y equals 3/4 x plus 2. Like that. Here's another variation. Requires a few more steps. Find the equation for a line that passes through these 2 points. So the first thing I want you to do is pause the video and just think about what you're going to need to do. Don't do the algebra yet. Just figure out what you're going to need to do and write that down. Let's see how you did. Your first step, find the slope. You can't do anything other than find a slope with these 2 points. So your first step, find your slope. Use your slope formula to do that. And then second step is use slope and a point to find the equation. And you're going to have your choice. You can use either one of these 2 points. If you did your slope right, you're going to get the same equation. So now, pause the video and do these 2 steps and get the equation for that line. Let's see how you did. First step, finding my slope. My slope plug in. Reduce, did the math, reduce down. My slope is minus 3/2. I hope you got that. If you didn't, take a look, see where you went wrong. Second step, I'm going to use the point slope formula for my plug-in. So it's y minus y1 equals m times x minus x1. So I did my plug-ins. My 2 is positive, so it's y minus 2. I'm using this point there, so that's the 2, y minus 2. And this is negative 1, so x minus 1, x minus negative 1 becomes positive 1. I moved my 2 over, I distributed my negative 3/2, I combined, and I have y equals negative 3/2 x plus 1/2. One more. Check this out. graph this line. That's a line in point slope formula. So let's tease out what we've got in there. Actually, before I start working it, you can do this. Pause the video and draw a graph of that line. Okay, let's tease it out. My slope is -2, and it passes through a point. It passes through the point 3, -1. Now that I have my information, I can make my graph. So let's go ahead and do that. Make my axes. I'm going to put my point on there. That's 3 -1. We're right there. Now my slope is -2. So that's -2 for the rise. So I'm going to go -2 down and 1 over. So I'm going to need to go down 2 and 1 over. So that's going to put me right about there. Make my line. And there we go. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.